Adhesion and cohesion talks about force of attraction. And so in adhesion is force of attraction between molecules of different substances, while cohesion is force of attraction between molecules of the same substances. So adhesion is force of attraction between molecules of different substances, while cohesion is force of attraction between molecules of the same substances. All right. So when you have force of attraction between molecules of the same substance, you are talking about cohesion. When you have force of attraction between molecules of different substance, you are talking about adhesion. Let's use water and mercury for example. We will ask you in exam, or mostly you want to wonder why does water wet glass and mercury does not wet glass. Let me show you how both behave. If this is a glass, so let's say this is glass now. When you pour water, it will wet the glass. Now this is glass again. When you pour mercury, it will form like ball-like stuff like this. It will not wet the water, it will be rolling. It will be rolling on the glass. Instead of it to wet, it will be rolling on the glass. But when you pour water, water will stick to the glass. What is happening? You notice that adhesive force between water and glass is greater than cohesive force between water and itself. Adhesive force of attraction between molecule of different substances, water molecule and glass molecule, they are different substances, so there is a greater attraction between them. This is mercury. So mercury does not wet glass. But in mercury, cohesive force between the molecule of mercury is greater than the adhesive force between mercury and glass. And that's why mercury does not wet glass, but water wets glass. You also look at capillarity. You use capillarity as another way to find the adhesive force and cohesive force. And what is capillarity? It's a different topic entirely. Capillarity is the ability of a liquid to rise in a narrow capillary tube, right? So let's look at how water behaves in capillary tube and how mercury behaves. So let's say this is water inside this container. First of all, you see that this is what you're going to have. Now you have a capillary tube here. So you discover that the water will rise. This is water. Let's see what mercury behaves like. This is mercury inside this capillary tube. Now, what do you observe? You observe that, first of all, water forms a U shape. The U shape is telling you that the adhesive force between water and the container is higher than the adhesive force, than the cohesive force. So adhesive force in water is higher, and that's why it rises in the capillary tube. When you look at mercury, the cohesive force between mercury and itself is greater. So it's kind of showing a level of repulsion, and you see that it's not rising in the capillary tube like water will. Do you understand? So you notice it's not rising like water is going to rise in a capillary tube. So you notice that what happened? One, water has a greater, in water, adhesive force, adhesion is greater than cohesion. In mercury, cohesion is greater than adhesion. That's it. So the force of attraction between the molecule of the same substance in that mercury, the force of attraction between its own molecule is greater than the force of attraction between the mercury and glass or the container. For water, the force of attraction between the water and the glass or container is greater than the force of attraction between water and itself. And this is the same reason why water wets glass and mercury does not wet glass. Now remember we said adhesion is force of attraction between molecules of different substances, cohesion is force of attraction between molecules of the same substances, and capillarity is ability of a liquid to rise or fall in a capillary tube, in a narrow tube called the capillary tube. All right, with this, I hope and I believe you know what is adhesion, cohesion, why water wet glass and mercury does not wet glass, and some of other things like capillarity. Make sure you like and share and subscribe to this channel and have a great time. Thank you and bye bye.